Hi, my name is Jeff Bao.
I'm Naomi Komatsu, and this is Mr. Renato's class, period 3 and 4.
In this lab, we were performing chromatography on various food colorings. Chromatography is a laboratory technique used to separate mixture in many fields of science. And this concept has two phases that goes through paper chromatography. One phase is the stationary phase, and the other one is mobile phase. The mobile phase is when the mixture moves by carrying different components of the mixture, while the stationary phase is when the mixture moves up to the paper through capillary action. Each component in the mixture has different attraction for stationary phase. For example, a component with such as high affinity will not be able to travel so far. And using the different affinity for each component, a mixture can eventually be separated into two distinct colors.
During this lab, we used paper chromatography and a sample of food colorings. We put dots of each substance on the bottom of the chromatography paper and let the substance soak in a centimeter of water for the class period in order to see how strong the capillary action was. The point of this lab was to see how far each substance could travel from where they were originally placed. Here's our chromatography paper after it's soaked in water and dried, and this is the beaker that we put it in.
So the RF value is the ratio of how the substance of a mixture has traveled versus of how far the solvent has traveled. So the RF value for this for the Kool-Aid was 0.527 for Kool-Aid 1, and Kool-Aid 2 was 0.318, and Kool-Aid 3 was 0.218. 2.18. 0.218. And one for the green, blue, yellow, and food colorings. These solute reveals that traveled much slower than the solvent in Kool-Aid 1, 2, and 3, while the solute and the solvent traveled at the same rate in green, blue, and yellow food colorings. The result of the experiment suggests that Kool-Aid 1 and 2 only contain red dye. Kool-Aid 3 contained red and yellow dye, green food coloring contained yellow, green, and blue dye. Blue food colorings contained only blue dye, and yellow food colorings contained yellow and orange dye. There are different components of each mixture and are clearly shown in the the picture.
Okay. For our post-lab questions, question 1A. The green, blue, and yellow food colorings were the most polar because they traveled the farthest, and the Kool-Aid substances were the most non-polar because they traveled the least distance. For question 1B, the reason that water molecules exhibit capillary action is because they contain strong hydrogen bonds and the adhesion of the water molecules. For question 2A, the least polar molecule is dye B because it is the closest to the starting front. And for question 2B, we believe that dye A is the unknown sample because it travels the same distance from the starting front as the unknown sample.